have two different versions. So far we've got two definitions of sine and cosine, the unit circle and SohCahToa. And the question is, why are they the same? Okay?
Okay.
So I'm going to go, in this case, I'm going to go from unit circle to SohCahToa, the first example that I make. So the first example would be, we're going left to right. So what I'm going to do is I'm going to start with some information about a right triangle. So we don't know the angle. We have an unknown angle theta. Okay? But we do know the measurements of a right triangle. And those measurements are .6. Actually, I should do it this way. I should do 0.8, 0.6, and 1. Okay? So we know that if I were to graph this on like an xy axis, so there's a y-axis, and there's an x-axis, then this point right here would be on the unit circle. And we know that this point, according to the definition, is what we call cosine theta, sine theta. Now I'm just leaving theta. It's not that we don't know the angle, it's that we don't know its actual numerical measurement. So I'm just leaving it as theta for right now. Okay, but we have this triangle, and we're sure that the adjacent to theta is 0.8, and we're sure that the opposite to theta is 0.6, and according to our unit circle understanding of trigonometry, we know that that means that cosine theta is 0.8 and sine theta is 0.6. Okay? So the question is, how do we get SohCahToa from this? Well, let's zoom out. And let's say in our travels one day, we encounter a different right triangle. And this right triangle, we know, has hypotenuse, it looks like about 3, according to my picture. And we don't know anything about this triangle except its hypotenuse is 3. But we do also know that it has the same angle as the right triangle we drew originally, which was on the unit circle. Okay? And so what do we need to know? We need to know, first of all, that these two triangles are what? What's the word describing these two triangles? Similar is the word that I'm looking for. So, all right, so these two triangles are similar. Okay, what does that mean about similar triangles? Well, first of all, let's prove that they're similar. That means that they have to have the same angles. Of course,
but
they
not
have
necessarily the same sides.
Exactly. They have the same angle here. That's because I hypothesized that. And we assume they're both right triangles, so they have the same 90-degree angle. And once you have two angles that match, the third angle matches automatically because they add up to 180.
Yes.
Okay. So now we know something about similar triangles. For similar triangles, the ratios stay the same.
Yes.
Okay. So what does that mean? That means that if I multiply 1 by 3, I also have to multiply 0.8 by 3.
Okay.
Okay? So that tells us that 1 over 3 equals, I'm going to call this side length here, we'll call it A for adjacent. 1 over 3 equals 0.8 over A.
Okay.
Agreed?
Yes.
Okay. So now what? Let's rewrite this as A over 3 equals 0.8 over 1.
Which you can just get rid of the 1.
Right. And so the right-hand side is
It's a
exactly
proportion.
cosine theta, right?
Mhm.
And the left-hand side is exactly a over 3, which we know as adjacent over hypotenuse. So in other words, I could start with cosine theta being the x-coordinate on the unit circle, envision a different triangle, a different sized triangle, and deduce that cosine theta happens to be adjacent over hypotenuse.
Okay.
And sort of the magic happens with the hypotenuse of the unit circle is always 1. Okay, and so I'll end. Let's try to let's do the other one. And of course, I did it for cosine. The same would work for sine. Let's call this A, B, and C. Right. If this is theta, I'll do sine theta for this one. So sine theta equals B over C.
Okay.
Right? This is the SohCahToa version. Right? So we're using so. Okay? So the question is, now, why is it that this size, why is it that this will be the y-coordinate on the unit circle? If I now go and I draw a unit circle, and I measure exactly the same angle, why is it that the y-coordinate is b over c? And of course the x-coordinate is a over c. Well, this one's actually sort of the same thing. If I know that these two triangles are similar, then I know that the ratio of c over 1 equals the ratio of, we'll call it b over y.
Okay.
Okay? Because I'm saying, like, okay, let's solve for this y. These are similar triangles. C over 1 equals b over y, right? So c over 1 equals b over y, solve for y, and we get that y is b over c. Okay, so just to recap the whole point of this video was that in this situation, I started with a unit circle, a point on the unit circle, and I said, here's cosine of theta. Why is it that cosine of theta is also adjacent over hypotenuse? Because here it's just an x-coordinate, and I had to think about similar triangles to figure out why an x-coordinate suddenly becomes the fraction adjacent over hypotenuse. And then the other situation, we went a lot faster through. I started with a random right triangle.
Okay.
And I said sine of theta is b over c. And I said, why is this also the y-coordinate on the unit circle? And again, I have to think about similar triangles. I'm taking a triangle with hypotenuse c, and I'm scaling it back down to a triangle with hypotenuse 1. Okay? And in the end, yeah, I think we'll walk away with this formula. The best way to do this, the best way to think about all of this, I think, is to just get this triangle in your head. If the hypotenuse is h, then the opposite side is h sine theta, and the adjacent side is h cosine theta.
Okay.
Okay? So this is like formula to live by.
Formula to live by.